These are the different key concepts that we will learn in this course, discussed point by point. First, configuring Python environment for developing AI projects. Second, specific role of Anaconda in keeping clear working environment. Third, Python environments and ways to set them up and begin coding. Fourth, the advantages of Jupyter Notebook for developing AI projects and compare it with another useful tool, Google Colab, with their advantages and disadvantages. Fifth, basics of machine learning models and different types of models available in the market and how to identify guidelines for using them. Sixth, basic deep learning models available and a few examples to learn and identify guidelines for using them. Seventh, basic demo examples and see how to implement those in Python.
Hi all, this is Lavi Nigam and welcome to the Python AI development course. Let's talk about basics of Python. Python is the most widely used general purpose high-level programming language currently available in the market for AI development. It is an open source programming language introduced in 1991 by Guido van Rossum and then further developed in the next 25 years by Python Software Foundation. By design, Python is and will be open source forever, which has aided in the adoption of artificial intelligence algorithms around the world. Let's have a look at why Python is so widely used in the AI industry. Python programming language is very interactive and easy to learn. It helps programmers write in far less line of code when compared to the other coding languages. Hence, it becomes easier for people who are new to programming to pick it up with fair ease. It is also easily scalable and easily maintainable due to vast libraries available for development. Python is also a multi-platform language as it can be integrated with a lot of tools very easily and can run in virtual platforms. It is easy to run Python on different platforms in secured way. Python can also be integrated with a lot of tools very easily and is also a cloud agnostic language, meaning it can work with different platforms, example AWS, GCP. It is highly modular due to its extensive support from different libraries and clean object-oriented design, which increases productivity. Although Python is widely used, each language, however, has its own advantages and disadvantages. Let's see some. Python is a very syntax-friendly language, which makes it easy for beginners to pick up. Python, being a multi-platform language, makes it easy to integrate with other systems and platforms. It also has powerful capabilities to be called from other programs written in C, C++, and Java. It is also an interpreted language which executes code line by line. Since Python is an open source language, it has a vast number of libraries to include wide actions like working with strings, PDFs, web service tools, etc. This makes it easier to build end-to-end programs much faster by simply importing these libraries. As Python is a high-level programming language, it can support both object-oriented and procedural programming language. However, as every programming language, Python has its own disadvantages. It takes much longer to run as it executes code line by line. While running the code in case of errors, it makes it difficult to debug the root cause if we do not follow a disciplined approach while writing our code. Since this is an interpreted language where code is executed line by line, it becomes harder to perform multi-threading. Python has its limitations with database access. The Python database access layer is a little underdeveloped and primitive. While running the code, the syntax varies between different versions as this is still an evolving language. Computers or machines are very archaic compared to the human mind. Unlike machines, we can easily understand any natural language after some training. However, in the case of machines, we need to translate our high-level languages into very simple code, often called as object code, such that machines can also understand our instruction. So essentially, interpreters and compilers act as translators between two entities which speak different languages. Before moving further, let's see the difference between interpreted and compiled languages. Interpreters do not interact with the machine directly. They convert the high-level language into an intermediate code, which in turn interacts with the machine. Interpreters allow high portability, which means the code is machine independent, which runs on virtual environment. So the code can be implemented across multiple systems. Languages like Python, Perl, PHP, MATLAB, Ruby, a good example of interpreted language. In case of compiled languages, the entire code gets converted into object code, which needs to be converted in machine instructions before execution based on the system it is running on. Hence, a code which is working in one particular system might not work in another. So changes in code require recompilation. Once the code is compiled, it has to be manually executed. Languages like C, C++, Julia are good examples of compiler languages. So now let's learn how the execution of both the interpreted and compiler languages is different from each other. In compiled languages, compilation of the entire code needs to be done before it can be executed, meaning the code needs to be converted into machine-readable format first. In interpreted languages, however, the code is already converted into machine-level instructions, so while executing, it quickly matches the functions and classes with the one present in the current environment. So no extra effort is needed for code execution as shown in the diagram here. In the previous slide, we have already spoken about the difference between interpreted and compiler languages. Let's now talk about some basic advantages and disadvantages of interpreted language. The first advantage of interpreted language is that it has a dynamic typing, which means compilation happens on the run. Because of this capability, interpreted languages have fast turnaround time of implementation, which improves developers' efficiency. Like we saw earlier, interpreted languages are run on virtual environments, which help in portability of the code. Since interpreted language are executed line by line, we can focus execution or debugging of single line or function at a time instead of execution of the entire code. Due to the focus execution capability, we can quickly debug any errors in the code. Now let's see some disadvantages of interpreted languages. Variable data type assignment is dynamic in nature, which poses problem with variable operations in future. They have a two-step process of executing the code, meaning first the code interacts with your virtual environment and then it gets converted into machine code, which slows the performance. They have their dependency of running the code on the virtual environment, so if the virtual environment or language version changes, we might get some unexpected errors. Virtual environments do not have complete access to the hardware and the memory that it is running on. Hence, interpreted language also have the same limitation as they run on virtual environments only. Now that we have understood interpreted language, let's see some advantages and disadvantages of compiled languages. Since compiled languages are already converted into machine code, execution is fast and easier. For example, C++ is faster than Python. As we already know, compiled languages are not dependent on virtual environments, so we have easier access to hardware of the system it's running on. Since the language directly interacts with the hardware, it has a better memory management. Since they are already converted into machine language binaries, they can be called self-contained languages. These languages are in the market for a long time. They have a very mature and clean debugging toolbox available for faster debugging. Now let's look at the disadvantages. Since they interact with hardware directly, they are very hardware specific and not easily portable. Prior to execution, compilation is necessary for checking correct syntax and generating bytecode for interacting with the machine. These languages have more control of the hardware interfaces, hence it becomes paramount for you to ensure you follow certain coding standards to make it more secure. The turnaround time for these languages is slower because we need to perform debugging and compilation before execution. Due to all the above complexity we discussed now, it is harder for new beginners to pick it up quickly. Now let's talk about the different kinds of tools which are available for AI. Let's see the landscape that we have for AI. Python is developing at such a high pace because of so many advancements in the hardware, infrastructure, and the variety of functionalities available as libraries for quick implementation. Because of the variety of tools available in the market, it is now easier to build new innovative solutions for a lot of common problems using machine learning, computer vision, etc. Python is popular in the field of AI as a lot of companies are focusing on developing this language. It is very easy to learn and develop even for people who are new to Python, and hence leads to fast prototyping. Also, a lot of tools available in the market have Python binding, which makes it easier for quick integration with Python. Let's go through some of the basic types of AI tools available for AI end-to-end implementation. Spark and Hadoop are common big data tools used in the data gathering pipelines that helps us perform actions on huge amounts of data at a large scale with fast implementation timelines. Both of these tools have Python binding called PySpark and PyHadoop for use in Python programming. Because not all data is stored and collected properly, hence we need to clean pre-processed data before it can be used. For this we have R, which is a famous statistical language available in the industry since ages. Another specific library, Pandas, is also commonly used in Python for data manipulation. Another set of tools which are necessary for building AI models are TensorFlow and Keras. TensorFlow is a very useful tool built by Google, which they are also internally using for AI innovation. And it helps developers build models easily at production scale. Keras is another high-level language built over TensorFlow and helps in quick implementation and enhances developer productivity. Once the model is built, we also need to manage how the model is performing in production to check if the data is being correctly interpreted or not, and if there are any issues, we might need to perform retraining of the model. For this, we use two tools, Metaflow and MLflow. The deployment of machine learning model is very different from the usual software deployment lifecycle. For this, we need to use AI-specific tools like TF Serving, Kubernetes services, which are similar to Docker and Azure. Finally, we need tools to smartly analyze and display data for business interpretation and package the results into easy-to-understand charts. This can be achieved using data visualization tools available in Python, like Tableau, Plotly, Dash, Streamlight, etc. Python is a more popular language for building AI applications than the more traditional languages like C, C++, Java. Let's take a deeper exploration why it is so. Some of the existing implementations of Python are already available in the market, as a library in Python can be reused by importing them in your code. Python has a large variety of open source libraries, which are tools available at your disposal for quick and faster implementation. Code written in Python is portable and hence can run on multiple platforms like Mac, Windows, Linux, etc. Python has an active community of coders and developers who are constantly finding new functionalities, which are open source and available for the public to use. Like we discussed earlier, Python is easy to learn for non-programmers. It has very simple syntax and English-driven coding styles, which makes it easier for people to read and code. Because of the vast innovation opportunities available in the field of AI, there is a huge demand of programmers and developers who have knowledge about Python. In this slide, we will talk about the widely available libraries in the market for Python development. Let's start with some. TensorFlow is a library that is built to create AI models for machine learning and deep learning. It is built by Google and is currently being used in Google internally. The scikit-learn library contains a lot of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction. NumPy is the core library for scientific computing in Python. It provides a library for processing high-performance, multi-dimensional array objects and tools for working with the arrays. Theano is a library used in Python for defining, optimizing, and evaluating mathematical expression using multi-dimensional arrays very effectively. Like we covered earlier, Keras is a library built on top of TensorFlow and Theano. It was developed keeping in mind that implementation of deep learning model needs to be fast and as easy as possible for researchers and developers. NLTK Toolkit is used for building Python programs to work with human languages, computational linguistics, and has a comprehensive API documentation. SciPy is a Python library used for scientific computation. It contains modules for optimization, linear algebra, and other mathematical operations for scientific community. Pandas in Python is the most common library used for data manipulation and analysis. It contains tools for reading and writing data between internal memory structures and different file formats. OpenCV in Python is a library for programming functions used for solving real-time computer vision problems. It is basically an image processing library which helps in processing of image at a very large scale to extract information from them. ROS is a robotic processing library that helps you implement robotic processing in Python using a set of inbuilt robotic functions. PyTorch library creates an interface with another language called Torch into Python. This language is essentially a very important language for deep learning implementation and helps in building high-level AI models. DLib is a unique open source C++ library implementing a lot of machine learning algorithms like classification and regression in C++. This helps us take advantage of C++ effectiveness and agility. And the last, Chainer is also kind of an implementation of deep learning library, but it is not very commonly used anymore as it does the same actions like TensorFlow and Keras, which are now more commonly used. Essentially, Python and AI go hand in hand, and it can be confidently said that Python has successfully taken up considerable position in forming the major foundation for AI for future technologies to bank upon. This slide is again an extension of what we have learned earlier. We will now focus on the most widely used libraries, which is why these are also the backbones of any AI implementation. Let's start with the first one, TensorFlow. Like we discussed before, TensorFlow is an open end-to-end platform built by Google, which provides functionality for machine learning and deep learning and reinforcement learning, and can be used in both development and research projects. The next one is scikit-learn. This is one of the most popular machine learning packages available for data science. It has wide coverage for all types of ML models like classification, regression, clustering, and pre-processing functionality built by the Python community. Pandas, which stands for Python Data Analysis Library, which provides fast, flexible, and expressive data analysis and manipulation tool. TensorFlow, scikit-learn, Keras, Theano, and PyTorch are all supported globally by industry leaders like Facebook, Google, Amazon, etc. Over the last decade, several languages partook in the race to become the go-to language for AI. The top two languages turned out to be Python and R. And even R, as we know today, is mostly inclined towards serving the academic purpose. So why and how did Python come at the top and become the primary language for data science and AI? Let's find out. Python has been developed under an open source license, which makes it freely usable and modifiable under certain terms. This encouraged a lot of significant contributions from the public over the years, which added to Python's numerous libraries, which are essentially wrapper functions for complicated operations. Since Python is open source, it has some great corporations who contribute by adding some great tools to the AI toolkit, which allow developers to build and deploy ML-powered applications easily. Some of the examples of this are TensorFlow built by Google, PyTorch built by Facebook. Python also has support for vast variety of tools, for example, processing huge amounts of data using Spark and Hadoop. It also has capability for integration with clouds like AWS, Google Cloud Platform, and Azure. While you're working on bigger projects, libraries can really help you save time and cut down on the initial development cycle. Python has an excellent selection of libraries, from NumPy and SciPy for scientific computing to Django for web development. For newcomers and beginners, Python is extremely easy to learn and implement. In fact, it is one of the most accessible programming languages available. Part of the reason is because of the simplified syntax with an emphasis on natural language. But it's also because you can write Python code and execute it much faster and easily. Python is not just restricted to the development stages, it is also equally proficient in delivering or implementing the solutions at hand. It can be used for building web pages, GUIs, networking configurations, and so much more. Python also provides ample support for managing big data and enabling cloud application. The applications written in Python can be production ready without any extra effort. Furthermore, Python and its libraries, even third-party libraries, have huge corporate support from industrial leaders like Google, Facebook, Amazon, and Microsoft, which makes Python even more dependable and reliable. Major industries look up to these grand changemakers who keep setting examples with major breakthroughs. With Python, the learning curve is very gradual due to its focus on readability. Also, it has been developed with beginners programmers in mind, as it is very easy to familiarize yourself with the language syntax. Also, due to the use of common expressions, you write less and get results faster. Now that we have learned the basics of Python, let's now compare Python programming language with other popular programming languages in the industry. The top two languages in AI, competitively very close, are Python and R. However, both cannot be extensively compared since they have different uses and advantages. In other words, both are important and serve significant purposes. Let's now learn a little bit about some salient features of Python and R programming languages. Python is a broad programming language, meaning it can perform a lot of actions like machine learning, deep learning, web development, network programming, etc. Python is also an extremely intuitive and user-friendly language which can be very helpful in building faster prototypes. Python is easy to implement and it is one of the most popular languages for integration with AI because of its binding with multiple platforms and cloud integration. Python comes into play here and supports fast-paced model development and deployment to building end-to-end application. R is an open source interpreted language for performing statistical analysis in graphs. R serves well in the academic sector where intense mathematical analysis takes place in order to discover new possibilities of data and algorithms. R also has a broad variety of visualization libraries for displaying data in more simple format. Because of its strong statistical analysis library, it is ideal language programming for complex maths problems. Let's look at some of the drawbacks of both the programming languages. Python sometimes lack some extensive ML implementations, meaning some of the applications are not entirely in Python. It might have external integration with other programming languages like C, C++. Since most of the libraries in Python are open source and built by the developers within the community, the detailed documentation might be lacking in certain libraries. Python also is not the most suitable language for building mobile applications and performing mobile computing. Our programming language has a steep learning curve, hence it is difficult for new programmers to pick it up easily. R also has a slower speed as compared to Python. R has its origin from an older programming language called S, and hence it has a weak origin for support for dynamic or 3D graphics. In R, the physical memory stores the object and requires the entire data to be stored in memory. Therefore, it is not an ideal option when dealing with big data. You have a lot of issues in R with respect to integration issues, and that's one of the biggest issues with R. Previously, we looked at the comparison between Python and R. Now let's look at some of the comparison of Python and C++, which is one of the most powerful general purpose and compiled programming language. Let's see some of the most common attributes of Python versus that of C++. Python is a very versatile programming language, hence it supports easy and fast AI project prototyping. It supports automated garbage collection, meaning the memory allocation and deallocation method is automatic as it interacts with the hardware only via virtual machine. Python is dynamically typed language, meaning the type of the variable is unknown until the code is run. Syntax in Python is relatively easy as it uses English keyword frequently, which helps in easy and quick implementation. Python has integration with cloud computing platforms, which enables developers to leverage computing power of some popular platforms without managing, maintaining, or configuring servers. C++ is the most powerful compiled language, which allows developers to access the hardware. It is one of the fastest programming languages as the code is already compiled before execution. It is also a statistically typed language, meaning the data types needs to be defined before it is compiled and executed. It also interacts with the hardware directly, so it is preferred language for implementing projects in the field of robotics, aviation, or anything which requires faster executions and deployment of the projects. Now let's see some disadvantages of both. Since Python is an interpreted language, there is a possibility of getting high runtime errors. Python code execution is slower because the code is interpreted at runtime instead of being compiled to native code during compile time. One of the restrictions of Python is that it is version specific and environment specific, so a correct environment setup is important before the program can be run. Since we already know Python runs via virtual environment, it has little or no control over the hardware it is running on. C++ has a very complex syntax as it is a low-level language that executes without the context of the interpreter. Hence, the coding in C++ is very tough. Since the memory allocation happens during compilation, we need to explicitly define variable data types. The libraries for machine learning in C++ are not only limited but also complex, so linking of libraries while coding for AI implementation might be a challenge. Due to its complexities, a proper architecture plan needs to be in place before implementing the end-to-end project that allows the different modules to efficiently interact with each other. We will look at an overview of implementing AI projects using Python and Java. Let's see some of the most common attributes of Python versus that of Java, which can be helpful for AI implementation. Because of simple syntax and not so steep learning curve, it makes it an easy for AI prototyping. It is an open source language and has huge community of developers who are constantly adding more libraries for implementation. Python has English-driven keywords, which makes it easy for non-developers to start coding. It is also powerful with an array of third-party libraries for almost every conceivable task, allowing developers to write far less line of code. Java runs on Java Virtual Machine, which converts the code in bytecode before execution, making it easier to write cross-platform code. Many companies have used Java codebases, and much of the open source stack for processing big data is written in Java. This means that Java-based machine learning projects will likely to be easier to integrate with existing repositories. Due to the bytecode verification before execution and strong memory management, it makes application in Java more secure and robust. It supports code refactoring, which helps finding, fixing bugs, and improves overall software design. Due to the above mentioned points, it makes it ideal for mobile and web application development. Now let's see some challenges while using Python and Java for AI development. Since we know Python code is executed line by line, so there is a possibility of high runtime errors. It executes code more slowly because it is interpreted at runtime instead of being compiled to native code at compile times. Because of the lack of libraries for mobile development, it is not one of the best choices for mobile web development. Before any Python code can be executed, all of the libraries need to be pre-installed, and hence it requires proper environment setup. Java has a steep learning curve due to complex syntax and strong coding principles. In Java, we need to explicitly define data types before execution. JVM requires large memory consumption as it assigns memory before execution of the code. Because of the complex software development lifecycle, it is not one of the topmost choices to achieve quick agile development. We have seen the comparison of Python with R, C++, Java. Let's see some other languages which can be used for AI development. As AI progressively moves towards becoming one of the top grossing fields, several languages are converging towards becoming the crux for AI development. Several new languages like Kotlin, Swift, Julia, and Rust are seeking close competition with Python. Let's see some features about Kotlin. Kotlin is a very new language with a restricted community. Since it is new, it doesn't have a lot of pre-built libraries. It has a fast execution as it has been designed to interoperate with Java. It is a suitable language for implementation and widely used for Android development currently. The next language is Julia. It is a high-speed implementation language mostly used for scientific computing and data processing. It is a fairly new language and hence has a limited community of developers. The packages are not well maintained and one might face issues occasionally while installing packages. The debugging feature available in Julia are not very efficient. Now let's look at Swift. It is a general-purpose, compiled language with high security and easy debugging developed by Apple Inc. for iOS, iPadOS, and macOS. It was built in mind to allow faster development time and to get a product which is foolproof. Thus, Swift projects are typically easier to scale. It is also interoperable with Python and JavaScript. It tends to be unstable due to frequent updates and poor interoperability with third-party tools and IDEs. The last is Rust. Rust allows efficient usage of memory and by automatically freeing memory whenever required. It is not very readable and doesn't have a lot of training resources available for beginners to pick up at this point of time. It has a very low runtime, meaning it takes longer to compile. Although it has a good amount of libraries, as compared to Python, they seem incomplete and immature. These new languages sure have some benefits. However, they also face certain issues which are bound to occur during the initial stages of any language. So that makes Python unbeatable and the most popular language for AI development, at least for the next few years. Let's see a few more points. Firstly, Python supports rapid development due to the fact that the packages are well tested and ready for deployment to ensure that minimum bugs arise when they go live. Secondly, due to its user-friendly syntax, Python source code is easier to read and learn than most languages, which allows you to read more code and learn faster from other people's example. Python has a huge community support with some major market players who also add their open source libraries to the public to use. Lastly, Python has vast variety of libraries to perform from the most simple and the most complex task in AI. It also has a strong binding with most of the third-party tools and IDEs. Python is an open source language. The vast community helps support the beginners as well as the expert developers and adds to the ever-increasing open source knowledge base. Talking of corporate support, Python has major supporters in the market, including some of the highly sought after industry leaders like Big Fives. Google, as one of the biggest companies, has contributed by building TensorFlow, which has spearheaded the world of AI with simpler APIs for building and deploying machine learning. Google actively maintains a library with various other industry leaders and has kept it open source for public. Facebook, as one of the biggest social media platforms, has built one of the major deep learning framework called PyTorch. This is an extensively used mathematical library in AI world, which is also open source and readily available for public use. Microsoft AI has developed CNTK to support conversational AI, machine learning, data science, robotics, IoT, cognitive modeling, etc. in a single platform. Amazon has MXNet, which is one of the very popular frameworks developed internally in Amazon, and it supports Amazon Web Services. CreateML and Theory is one of the major frameworks which has been developed by Apple for deployment of machine learning models, majorly used in various ML related tasks, that is recommender system, text classification, etc. Python has some of the strongest corporate support, which helps the language improve and solve more real-world problems with innovative solutions. Let's quickly go through some of the benefits of corporate support. Owing to the corporate competence, industry leaders take major steps to improvise the already existing technologies. In order to do that, they employ the best talent to work on their systems. This not only enhances the quality but also raises the bar for further development or updates. Due to the frequent updates, the packages are constantly improved to avoid any issue faced by the wider community. For staying ahead in the market, each new package available makes the implementation easier for faster delivery. Support from industry also encourages greater influx of developers and learners into Python community since they see greater scope for language in the near future. This strengthens the community and enables speedy solutions to bugs and doubts on active public platform. With each update, the management gets better and organized for building a robust and secure programming language. With the strong industry support, the demand for language has increased over time. This has led to detailed documentation of packages and a higher degree of organization to enable the language for a larger audience. We have seen that Python's inbuilt as well as third-party libraries are one of the major reasons which makes the language a favorite in the AI circuit. Among these, we will discuss the most popular in this video. Pandas and NumPy are the most used libraries for data collection, pre-processing, data manipulation, and analyzing the data. This process is very significant as it heavily affects the later stages of model building and feature creation. TensorFlow and Keras are machine learning modeling libraries. Scikit-learn and SciPy provides very useful wrappers for building machine learning models and algorithms. PyTorch is another advanced learning library for machine learning, which is based on Torch programming language. Once the model is ready, Metaflow and Airflow helps in model management and testing the whole model with new data or retraining if required. Now let's learn more about these libraries in a bit more detail. TensorFlow was mainly developed by Google's Brain team for their internal use. It was released to the public in November 2015. It has a flexible architecture with which it can run on a variety of computational platforms like CPUs, GPUs, and TPUs. TPU stands for Tensor Processing Unit, a hardware chip built around TensorFlow for machine learning and artificial intelligence specifically. It also exposes a very stable and backward compatible Python and C++ APIs. Keras is an open source library used for neural networks in machine learning. It also has a bunch of features to work on images and text that come handy when writing deep neural network code on both CPU and GPU. It can also run on top of TensorFlow, Theano, R, etc. PyTorch is an open source library based on Torch, which has a range of tools and libraries that supports computer vision, machine learning, and natural language processing. It can smoothly integrate with the Python DataScience stack, including NumPy. It also allows developers to perform computations on tensors. PyTorch has a robust framework to build computational graphs on the go and even change them in runtime. Scikit-learn library was built as part of Google's Summer of Code project on top of two Python libraries, NumPy and SciPy, and has become the most popular Python machine learning library for developing machine learning algorithms. The main machine learning functions that scikit-learn library can handle are classification, regression, clustering, dimensionality reduction, model selection, and processing. If we can start coding in Python, we need to set up the environment. Let's learn what are the requirements for environment setup of Python. Anaconda is created by Continuum Analytics, which is an enterprise-ready, secure, and scalable data science platform that empowers teams to govern data science assets, collaborate, and deploy data science projects. It uses two main languages, R and Python. Anaconda is popular because it brings many of the tools used in data science and machine learning with just one install, so it's great for having a short and simple setup. It is great in terms of dependency of operating systems. It has different versions for different OS. With Anaconda Navigator, you can have different versions of languages on your computer and easily switch between them by keeping them in different environments. Let's see why Anaconda is a suitable option for programming AI projects in Python. By using Anaconda, you can install different packages that are required for AI development very easily. As we have had learned earlier that Python is a version and environment specific language, so Anaconda capability to maintain separate working environment comes in very handy. Each Anaconda version can be installed with specific Python version, example Python 2.6 and Python 3. Python can be used in various ways through different platforms and integrated development environment called IDEs. All these IDEs serve the common purpose of solution development, but do so by providing the user with different and unique features. Let's see some of the different IDEs available in the market. Talking of Python IDEs, the most popular IDE is PyCharm, which has high sophistication when it comes to code navigation, refactoring, and debugging. You can connect to local and cloud repositories of code and work seamlessly between both. It is a versatile IDE which supports popular web frameworks like Flask and Django. It also supports all the vast Python libraries and tools like scikit-learn, Keras, TensorFlow, etc. Anaconda has another IDE called Spider. It is only suitable for data and model analysis and is not a good fit for deployment purposes. Spider is very lightweighted and therefore very fast. It also supports multiple plugins, which is sort of good thing in terms of AI. Similar to PyCharm, Eclipse IDE is also very supportive in similar ways and can even host several languages apart from Python. It enables easy management of integrations and plugins. It also supports auto-completion, code refactoring, easy navigation, and strong debugging interface. It is often encouraged to undergo solution implementation through PyCharm or Eclipse. Another Python IDE is Atom. It works cross-platform, which is a major advantage. There are a lot of extensibility option of editor handled through an inbuilt package manager. It also supports auto-completion. It allows splitting the interface into several screens for code comparison. Though rarely talked of, Atom is a proficient platform with code auto-completion and package management facility. Other than IDEs we just saw, there are few new emerging IDEs which are gaining popularity. Google Colab and Jupyter Notebooks are two of them. The main features of both of them is that they are interactive notebooks which help data scientists for quick exploration tasks. Let's quickly learn more about them now. The main advantage of Google Colab is that it does not require any local system setup. It is ideal for instance learning purposes. It also provides GPU service for free, which is difficult to obtain in local system. It has several pre-installed libraries. However, the only problem with Colab is that it is unable to handle large datasets and refresh after every 24 hours of continuous run. This is not preferable for advanced MLDL and big data problems since they usually require long hours of running time and have high memory consumption as well. Most real-world problems therefore cannot be solved with Google Colab. Furthermore, it is easy to collaborate with other developers easily with the help of shared Google Colab links. Jupyter Notebook requires local setup before we can proceed with coding. It also supports autocomplete and help for any issues. Jupyter brings a lightweight interface for kernel languages that can be wrapped in Python. In Jupyter Notebook, it is also easy to create documented walkthroughs. With time, Jupyter Notebook has growing support for a variety of languages like R, Julia, etc. As compared to Google Colab, Jupyter Notebook has difficulty in collaboration with the users. Numerous websites are made using the Python programming language. Many top companies are developing successful apps by using it. This is why it is considered the language of today and the future. Python has a long way to go now that it serves as a backbone for AI. With its ever-growing community of developers, researchers, and learning enthusiasts, it is getting optimized and improved upon every day. As the demand for AI professionals are increasing, so is the demand for Python as a skill. This means that over the years, the industry will gradually incline towards experts who have a good hold over this language. Many firms have even proposed migration of their system from old code to Python-dependent software. Either that or enable new Python integrations such that legacy systems can work with Python moving forward. Over the next few years, a lot of development will take place in deep learning and machine learning, and most of them are expected to take place using Python as the major language. These will certainly become the legacy system for the distant future and lead to a Python development environment for future AI software. In the next decade, however, Python is expected to have several competitors, but its strong reserve of libraries and worldwide community support will probably become its most coveted features, since these require a long amount of time to develop and the new languages are only just beginning to explore their possibilities. Now that we are at the end of the course, let's quickly summarize what we have learned in this course. Firstly, we went through the Python overview and some basic principles of the language along with its advantages and disadvantages, and some basic of interpreted and compiled languages. Next, we compared Python with all other languages, why we use Python for AI, and reason why Python is the backbone of AI, and did a deeper comparative analysis of Python versus other popular languages like R, Java, C++. Next, we briefly learned about setting up Python environments and configure Python Anaconda environment and advantages of using Anaconda. We also covered different IDEs available for Python development, also the different libraries available in Python. And finally, we learned why Python is so popular in the market and the future of Python for AI development. In the upcoming Python AI development course 2, we will go a little deeper on some of the sections we covered in this course. We will learn how to set up Python environment in detail and learn about different ML and DN models available in the market for AI development. Python as a programming language and recognize its role in AI development. Learn the basics of interpreted and compiled languages along with its advantages and disadvantages. Learn the basics of interpreted and compiled programming languages along with its advantages and disadvantages. We will also see the major AI tools available in the industry. Next, we will identify the advantage of using Python when developing AI systems and the multiple factors that make Python as one of the most popular programming languages. After that, we would compare the use of Python in the field of AI with different programming languages like R, C++, Java, and some of the new programming languages like Julia, Rust, based on their functionalities and performance. We would also learn the role of Python AI development in the industry and the various Python libraries available in the market for AI development. We would also learn about the different ways of utilizing Python using various IDEs like Atom, PyCharm, etc. and different cloud platforms. Lastly, we will learn about the prospects of using Python for AI development in the upcoming future. Hi all, welcome to part 2 of Python AI development. To get started, the first item in the checklist is to create a suitable environment for building your AI applications. Setting up an environment for AI application development is very simple when compared to the older technologies. Since most of the tools used in the AI are open source, a lot of contributions and improvisations over the years have led to a hassle-free setup process. Let's get straight to how it is done. In this slide, I will be walking you through very basic setup of Anaconda AI environment, and these are the following steps. First, make sure the Anaconda distribution is installed such that you can leverage its features. Once you're sure that the Anaconda package is installed, go to command prompt and type Anaconda prompt in the search space on the start menu. Second, we will start by creating a basic AI environment. Creating a different environment for each application helps to isolate the application from other applications so that the package requirements of one application does not cause problem for the others. A virtual environment can be simply built with the command conda create, as can be seen in the slide. It is followed by a dash and a n, which acts like a project name identifier. Type in the name of your project followed by a space. then the Python version that you require, and then followed by all Python libraries. Some of the common libraries that you can use to set this up are scikit-learn, NumPy, Pandas, and SciPy. Like we learned in the part 1 of the Python AI development. Make sure you write correct names of the libraries. Once you run the above command, after a couple of seconds, you will be prompted by word proceed as a trigger. Type Y and press enter. After a while, the command prompt will show the environment is ready. Third, type in the command conda active, your project name, to activate the environment. Make sure you type the correct name of the project. Fourth, the last one, since it's easier to work with the GUI-based Jupyter Notebook than on the command line, run the command Jupyter Lab to open the Jupyter web application in the activated environment. After completing all these steps, congratulations, your AI environment is ready. After setting up the AI environment through Anaconda commands, we need to start working towards building the application, which will also be aided by the Anaconda distribution. Therefore, let's understand the features of the distribution first. There are several benefits of using the Anaconda distribution. Let's discuss the most important features. First and foremost, it is developed under the open source license, which means that there is always a large scope of improvement. Any open source software is exposed to a large set of developers worldwide who provide essential insight on the core code and also contribute third-party packages, which increases the functionality of the distribution by many folds. It is also easy to manage since it can be operated through a simplistic GUI, which means that you have an option of managing packages and the development platform through a single click of button. It supports the topmost languages used in AI, which are R and Python. This means that not only the corporate sector, which heavily depends on Python, but also the academic sector, which uses R intensively, can rely on Anaconda. This also makes integration of these two counterparts more plausible feat. Anaconda's library manager has a record of supporting over 7,500 libraries and thus can support development of all basic applications with minimal effort. It automatically takes care of library package dependencies such that manual effort is reduced. For instance, if you want a package, for example, Pandas, which depends on 3 other packages, let's say X, Y, and Z, while downloading a package for Pandas, Anaconda will make sure to also install X, Y, and Z with supported versions. Thus, 4 packages will be installed with a single command. Furthermore, it is prompted and supported by several industry leaders in the corporate sector, which gives users a sense of reliability and trust. Apart from this, Anaconda also comes with enterprise technical support through their engineers, which makes it easy for companies to adopt quickly without the worry of security and long-term support. Anaconda is, however, not the only distribution available. Datmo is a similar distribution, and this is how its features compare with that of Anaconda. Datmo enables research, deployment, and even scaling, whereas Anaconda is restricted to the research and development stage. This means that even though solution can be built on Anaconda, deploying them to the end user will require use of other platforms, whereas with Datmo, it is an all-in-one platform. Datmo comes with pre-built AI environments along with centralized dashboard to track different experiments. On the contrary, Anaconda requires the user to set up virtual environment along with the required packages manually. Also, Anaconda does not support a dashboard to track the several experiments that are often part of any AI experiments. Deployment is possible on cloud with single line commands in Datmo, which is entirely impossible with Anaconda. Thus, Datmo does not only support deployment but also makes the process user-friendly. Docker, a containerized development platform, is pre-configured in Datmo, which helps users to deploy the application in isolated containers, which makes the application highly independent and production ready. This is also a missing feature in Anaconda. However, Anaconda beats Datmo in stability since it has been around for long, and Datmo is comparatively very new, which makes some of its features unstable, specifically after version updates. This makes Anaconda more suitable in terms of reliability and consistency. The Anaconda distribution, as we have already seen, provides several features and facilities. One among them is the Jupyter Notebook, which is a web application that runs on the browser. It is a programming tool and is mostly used during the experimental or model building phase when critical data analysis and documentation is necessary. Jupyter Notebook is a very popular tool among data scientists and analysts, and for a good reason. There is a scope for people from different technical or non-technical backgrounds to work with Jupyter since it does not follow any coding standard or discipline. One major advantage is that it supports visualizations and documentation in the notebook itself. Therefore, the user does not have to run a piece of code every time he or she wants to look at particular visual. Once the visual is generated in the notebook, it is there to stay unless overwritten with some other output. Jupyter supports both R and Python, the two most in-demand and most used languages in AI. Therefore, it can be used easily by two major sectors, the corporate sector, which is mostly Python dependent, and the academic sector, which is more heavily inclined towards R. The notebook is divided into several cells or paths, each of which is an independent line of code, except for variable dependencies, which is also not a problem since every cell in a given notebook accesses the same memory unit. This makes Jupyter a very easy to use platform for both programmers and non-programmers, since the coding standards become extremely lenient due to the cell-wise breakup. You will see the demo of Jupyter Notebooks in our demo sessions. Coming to the features of Jupyter Notebook, these are one which set Jupyter apart and makes it popular choice among AI developers. It's an all-in-one platform which allows coding, visualizations, command line operations, and even documentation. All these features are extremely important in any experimental setup and thus allow developers a great degree of comfort when it comes to compactness. Jupyter Notebook is easy to convert to other preferable formats like .py Python script, HTML for web pages, or even PDFs. Sharing and customization of the notebook can also be done mostly through GUI-based operations. Jupyter also supports extensibility, which means the addition or integration of new functionalities are easy. Each experiment can be tracked and documented in Jupyter through its all-in-one platform. And for its sequenced set of cells, it is also possible to reproduce the experiment results along with their respective outputs. Jupyter supports interactive coding, which allows user to provide their inputs during runtime. It is also an apt tool for data exploration since it allows the visualization to appear in the same space and also saves time for comparison. Google Colab is similar to Jupyter Notebooks, with the only difference that it runs on Google's cloud instead of being connected to the local system and is available for free to users. Now let's see what are the key attributes of Google Colab. The main advantage of Google Colab is that it is entirely independent of the local system setup since it runs online on Google's cloud. This means that the user does not have to worry about the configurations before starting an experiment or project. The users can leverage Google's cloud hardware facilities, including strong processors like GPU and TPUs, and all this for free. These services are often very difficult to bring to the local system and thus is very valued facility. Colab comes with pre-installed libraries from Google, including all major AI Python libraries, so it saves time in setting up the environment. In case some libraries are missing, they can be easily downloaded through the pip package manager, which is also integrated in Google Colab. Now that we know what the key attributes of Google Colab are, let's see what are the most prominent features of Google Colab. The Google Colab notebooks are saved on Google Drive by default since it runs on Google Cloud System, which means it is easily accessible whenever and wherever you need. The notebooks developed by a user can also be shared and integrated with other users' input through simple online link sharing, and just like in Google Drive, revisions and version controls are also possible in Google Colab. Thus, it can be said that Google Colab facilitates a high degree of collaboration. The only drawback with Google Colab is the fact that it can get refreshed every 8 hours and all your work might get deleted. Repository integrations with GitHub and control of notebook versions are easily achievable through Colab's GUI. Google Colab has a link to Stack Overflow, meaning it will directly search for any errors you might get during the execution on Stack Overflow wide forums. Since the notebook can be saved on Google Drive, they can be uploaded and downloaded to local systems easily. A very interesting feature of Colab is that inputs can be taken from users through forms inbuilt in the cells. In other words, Google Colab does not only support interactive code, but also makes the interaction presentable and easy to operate. So the goal of this video is to understand explanatory data analysis, or it is called as exploratory data analysis, or EDA. And we're going to see how it is sort of done very easily through Python. So you'll be able to take your data, do certain analysis from a graphical point of view. You will be able to visualize all your data points so that it becomes quite easy for you to make certain predictions and help you do the modeling stages of the AI world. Now to achieve this, we're going to use a very advanced library called Plotly Express. Now there are very good things about this library. One is that it can help you do a quick visualization by just doing a single or maybe 2 or 3 lines of code. So their principle of creating this library was quite simple. They just wanted to do something where people can just write a single line and they should be able to do multiple different visualizations. So that's what one of the goals is. And similarly, the other goal that this library has is that it can help you get interactiveness inside the graph itself. The data that we are using for this is a data that consists of marks secured by students in various subjects. And this data is available on Kaggle. The inspiration is to understand the influence of parents' background, test preparations, etc. on the student performance. And it has total 1000 rows and 8 columns. Typically, the columns that we have are gender, the race and ethnicity, the parents' level of education. We do also have lunch, whether they do take standard or free. We also have test preparation courses, whether they have done any preparation or not. And then we have 3 specific courses: maths, reading, and writing. Now, just like we every time do, you can see that we don't have to install any of these libraries because it's already there in the backend that we are using. So we're going to quickly run through and connect to the backend while it is connecting, which sort of gives us the access to the environment where we are going to work on. Now the data is already available as a study material. So you just have to import these 2 libraries, which is import pandas and import plotly.express, which is the library that we're going to use. Now, if you see this data, you can see that we have a gender, we have ethnicity, which is into groups. So we have group A, B, C, and D. Similarly, we have level of educations of parents. So we know whether they are bachelor degree, they have some college, some masters. We also know whether they go for lunch, test preparation is done, which is whether they have completed it or they have not taken any courses as such. Similarly, you have math, reading, and writing score. This is out of 100. So you know that each student has a specific row. So each row here represents a student, and we know their specific courses in maths, reading, and writing. Now what we're going to do is we're going to do a couple of graphs so that we can understand the whole representation of the data. So the first thing that we do is we just quickly try to understand the numbers of specific categories. So we can see that by just doing a simple count, we can get to specific things like, similarly, most of the students have better quality of lunch, which you can see that, 645 have done standard and 355 have taken free and reduced. So majority of them have standard lunch. You also have good distribution in terms of ethnicity, except the group A where you have very less amount, and group C where you have large amount of students, which we'll see also the graphical representation. We also see that majority of the parents in the data have done some level of degree, and couple of them have also done just the high school, and majority of them are essentially all the high schools, but they are good educated people who are part of this. So again, the goal of this data is to sort of see whether there is a pattern which emerges wherein we can sort of do a combination of performance of the student versus all these different things that we have taken in the data. Now the first thing that we're going to do is we're going to see the same thing, which was the gender, and you can see that we have drawn our first graph. Now this graph is a bar plot. You can see that it has just a single line, and you can see the way I said this is interactive is because if you hover around this graph, you can very easily see the points or the counts, whatever is there in the graph. You also have an option available at each graph, and you can see that the graph comes right inside your notebook. and you have an option to save this. You have an option to auto scale or reset. So if I just want to select this, for example, I can again go back to home and I can reset the axis. So this is where the interactive element comes into picture, which is to say that you have huge amount of interactivity available. Now the next thing that we're going to see is we're going to see the comparison of gender and ethnicity. Now this graph is, again, it's easy to draw, but it's not very clear in terms of what is that we are trying to get from this. So we do a different graph here. So we say that let's divide that into multiple bar, and in this case you can see that we have male and female, and we have divided this into just by giving a grouping. So we are saying let's just see female specific ethnicity and male specific. And again, if you see the code of it, it's just a matter of defining what is the group you want, what is the color you want, and what is the X value that you want. So now you can also clearly see that ethnicity C, which is the group C, has larger representation of people, and typically ethnicity group A have the lowest number. So that's what we have also seen previously with the non-visual way, and now we are seeing the visual way. We can also do weighted sum of it, so which is to say that now you're seeing the graph which is slightly more weighted compared to the previous one. Now let's do some other graphs wherein we try to see a very basic pattern emerging out. So what we essentially want is we want to see that is there any pattern from the gender male and female with respect to maths and reading scores. And that's why we are drawing a plot which is a scatter plot where we have maths and reading as an X and Y, and we want to divide the color by the gender. So that's why you see the reds and the blues. So you also have a legend here. So you can see that we have blue as a female and red as a male. Now, if you notice, you can actually do hover around any points and you can actually see the individual values of it. In fact, one of the things that you can also do is, let's say I just want to see what are the people who are performing very good. I can just do a selection in the graph. Once I do the selection, I can very individually see that who are those people who are sort of making good amount of higher scores. In fact, that on a higher marks, which is more, whether the males are more or the females are more, right? So that's one way of doing it. I can also do a distribution of these things. So I can see that for the reading, I have a distribution that what is the distribution of the marks. Like in general, are people scoring on average or people are scoring more for the score? So you can see that both of them look quite normal from a distribution point of view, which is to say that majority of the people are essentially scoring on the average scores, and that's one good thing to look into. Now similarly, we'll see something which is sort of male female, but then we'll also see something which is from the point of view of ethnicity. So in this you can see we are doing a box plot. Now when you do a box plot, one of the very interesting thing is it sort of gives you different ranges of your data. So you can see the lower end of ranges, which is if you see the male part, you have the lower fence at 30, which is to say that these are the lower scorers, and then you also see the max which has gone to 100, and you see the different quantiles that we have talked about in the previous video. Now from this graph as well, you can see that males are slightly performing better, but you do have a lot of females who are not performing very good, which is why you see the points here which are slightly an outlier, which you need to keep in mind. Now we're going to do the same graph, but we're going to add the ethnicity now, but we don't have a male female characteristic in this. So we're going to go ahead, and again, if you see, it is just like putting a value in the functions, and you will be able to create a graph where now you have males and females both in a single analysis. Now, couple of analysis, if you see the graph, you can sort of make is that Excel in maths is a male of ethnicity group E, which is to say that Group E has better mathematical scores compared to Group E of the females. Similarly, in general, you can see with specific ethnicity whether males are performing better or females are performing better. So that's the kind of analysis you'll be able to do in this using this library, and that's what we are trying to see in this video. In this notebook, we will see the basics of data pre-processing on Google Colab environment. You will be for the first time be able to see how Python has made the whole process so easier for you to do any pre-processing for any of the AI models that you have to do. Before we go into data pre-processing, let's quickly see some of the features of Google Colab that we have covered extensively during the presentation. Before moving to data pre-processing, let's see some of the overview of Colab, which we have covered extensively in the course. Now, one of the things which is that we have talked about is Colab is nothing but the Google ways of putting Jupyter Notebooks online. So what it does is, if you sort of see that you have the same functions of cells like you have in the Jupyter Notebook. So for example, you can add a cell and you can do your Python coding here very easily. And one of the great things about Colab is what we have discussed during the course as well, is that you don't have to do a lot of installation. So currently I'm actually installing a library called pandas. Now if you just run this up, you can see that I'm able to run this quickly. Now one of the things that you always have to do while doing Colab is the fact that you have to connect to the backend. So this is one of the precursor step of doing anything in Colab. So currently you can see that it is doing a connection with Google Cloud Engine, which is at the back end of it. Once it is connected, you will see a green arrow, and if you just hover your mouse over it, you will see that it's a 12 GB machine which is sort of given to you for free. And that's what the beauty is. You don't have to work on your system and you can completely work on Google Colab. Another thing that you need to understand is that you don't need to install any environment, because you are getting a machine which is specific to what you are trying to do in this whole notebook. So you don't have to set up a separate environment for this thing. The other thing is, inside runtime, you can actually see that they give you an option of different versions of Python. So you can actually work in 2 different versions. Similarly, you can actually see that you have an option of GPU as well as TPU. Now, TPU is tensor processing unit, which we have seen a very bit in the course. But GPU is something which is very important for you to do any amount of deep learning models, not necessarily for machine learning. Now that we have seen a very basic of it, so just like I said, it works very similar to Jupyter Notebooks. So all and everything works on the concept of cells. You write your Python codes in the cell and it sort of gives you the feedback of whatever is the print of those statements right in that. And we'll see a couple of examples of that. So one of the things that I'm doing in this notebook is I'm importing 2 of the libraries that are going to be used. One of them is NumPy. NumPy is essentially used for any array level computations. The second library, like we discussed, is Pandas, which is for any level of tabular data structures that you need to do a manipulation on. So the first thing that I'm going to do is I'm going to read the data. Now this data is very simple. It sort of has an outcome, which is whether somebody will have a diabetes or not. So we know whether what is the glucose level they have, what is the blood pressure they have, what is the skin thickness that they have, the insulin level, the BMI, the pedigree function, whether they have a diabetic person in their family or not. So the goal of this problem statement is very simple, that given these different levels of information about a patient, can we do a prediction of whether somebody will get a diabetes or not, which is what you see as an outcome column, which is where we already have historical data where we know that which of these people got the diabetic condition because of these things. So 1 represents that these people have diabetes, and 0 represents that they don't have diabetes. So the goal of this notebook is not to do that prediction, but just to show you that before even going to the prediction, there are certain things that we do before that. So the first thing that we are doing is we are trying to see whether we do have any values, because the problem with the data is, if you actually observe the head of the data means that you're just seeing the top 5 rows. If you see that, what you will notice is that some of the values in a row, specifically for column insulin, you don't have any value. Whenever you don't have a value in Python for a specific cell inside a CSV or a data that you're trying to do a prediction on, it is represented as NaN, right? Now, when you have NaN values, what you typically try to do in this NaN is you would want to address them. Now, addressal could be a fact that you want to remove them because you might be under the assumption that maybe this is not useful, or you might want to fill it with certain values. A value could be median of that column, or it could be a mode of that column, any of those level of details. So that's what we are doing here. What we are essentially doing is we're just using a single hand function which sort of calculates how many NaN do we have, and we get a tally of those things, and see how easy it is just by using a single line of functions. And that's one of the power that you will see across the notebook, that we are not writing too many of codes, and yet we are able to get information so quickly. So in this tally, you can see that insulin and skin thickness has huge amount of missing values slash NaN values, which is the fact that we need to do something about it and we need to do a addressal like we discussed. So what I'm doing in the next one is I'm addressing by removing those values. So you can see that again we have a direct function which is drop NA, and in this function basically I'm just removing all the rows wherever I have a NA value, which is to say that if you do the total of these numbers, this is how many rows that will be dropped from the overall data set. So like I said, you have various different ways of doing the addressal. One is that you just drop the values. The second is you can just do the fill of those NaN value by taking a mean of that column, right? For that, we again have a very straightforward library in sklearn. So sklearn again is scikit-learn, which we have discussed during the course, which essentially has all the machine learning algorithms and necessary libraries which can be useful for you to do any kind of algorithm. So this is one of the examples where we are using that library to call a specific function called simple imputer. What simple imputer does is very simple, that you just let it know that, hey, I want to take all the NA values and replace it by a specific strategy. In this case, the strategy is mean, so it will sort of replace the whole value by the mean of the complete column. And that's what we are doing. And you can again see that, we are just able to do that by using just a single line of the code. The second strategy that you can follow along is by doing a median, which is to say that rather than taking a mean, which is always affected by the outliers when you take an average or a mean, but when you actually take a median, it is not affected by the averages. So it's a better strategy compared to the mean strategy that we just saw. So it depends which one would you want to go ahead and sort of do that. Other thing that we do in our data, which is quite challenging and which is very important, is to find the outliers in the data. Now, what do we mean by outliers is very simple, that any data which doesn't fit with the consistent distribution of your data, that maybe there are some very few points in your data which is going completely beyond the general distribution of the data. We try to understand those data points and we try to get rid of them because they might add a bias to your final analysis. So you can see that we do have a function that we have written here, and this is a very template driven function, which is to say that you can just take this function and use it in any data frame or any data that you have. What we are essentially doing is we are trying to figure out two quantiles of our data. So we are taking the first quantile, which is 25 percentile, and the second quantile to be 75 percentile. Now these 25 percentile and 75 percentile is very simple. What we are essentially trying to say is that tell me the first 25th percent of the data and tell me everything which is beyond the 75th percent of the data. And that's what we are trying to understand, because again, like I said, our goal is to clip the data of the ranges which is slightly beyond the general consensus of the data, right? So that's what the function that we have written. Now, once we have written the function, so you can also see the power of functions that we have in Python, that I have just written the whole function in a very general format. This is again a very OOPS way, the object oriented way of doing things. So you have some ways of doing that in Python. So we have written a definition which sort of does the figuring of all the 25 and 75 percentile, and we are taking the 1.5 of that value. So we're not exactly clipping everything which is lesser than 25 and greater than 75. In fact, we are saying that 1.5 times of that values, whatever is lesser and whatever is higher, and we are defining that by floor and ceiling. We are trying to remove that. Now, once that function is written, you can essentially see that we are now passing all the specific columns. So you can see that the data frame that I had, where I have loaded the CSV file, which is now in the format of data frame, I'm basically able to get each and every column, and these columns, we are passing it to directly the functions that we have written, right? Once the functions are, sort of calling the data that we have, in this way, what will now happen is that you will be able to get the outliers, and you will be able to get what are different kinds of outlier based on the conditions that you have defined. Now, once we get those, it is very easy to just drop those columns, because now we can just say that, hey, in the BP, which is the blood pressure column, I have the indices which seems like an outlier. Just drop them. So you can see that we are just using a simple function and we are just dropping the whole of it, right? Similarly, other way of doing is you can actually take a min of a value to do the imputation. Imputation means again the same thing, that if you have a missing value, you might want to take a min also. So people do max, min. All of these are different strategies to address the issues in your data, which comes under the pre-processing aspect. The second thing is normalization and reduction. Normalization and reduction is very simple. Certain time you would want your data to look like in a single ranges. Now, if you go up and if you actually see your actual data, you might wonder and say that, hey, there are some values which in which the ranges are 6, 1, 8. There are some values where the glucose ranges are somewhere around 80 to 150 or something like that. Then you have skin thickness in a different range. Then you have blood pressure in a different range. And that's a problem from a mathematical point of view. And this is what we try to achieve while doing a scaling and a normalization, which is to say that we try to put every data into a single scale so that the algorithm can understand everything from a single point of view rather than understanding in a different scale altogether. This also helps in doing faster implementation of the algorithms. If you have different scales, then algorithms will take time to converge. So the better would be to just stick to something which is going to work on a single scale. The reduction part of this is very simple to understand. What we do is, again, if you see the whole data that we have, which are multiple different kinds of columns that we have in our data. Now in this data, what typically happens is that you may or may not need all the columns, right? It may so happen that model figures out while doing the learning that there are some columns which are not useful to do the prediction, or they might be adding as a noise while doing that prediction. So what it does is there are so many techniques which are available, and they are typically part of feature extraction or dimensionality reduction. And this is what we are trying to do here. One of those algorithms are called PCA, which is also called as principal component analysis. What it does is the moment you throw a complete data to this algorithm, it is going to convert the whole data into smaller columns, and it might give you something like, let's say if you have n columns or let's say 10 columns, then you might actually just get 2 or 3 columns which will represent complete information of those 10 columns. A very similar way of understanding this is that you can think of it like a compression, like you have an image or a file, you're compressing it to a smaller format so that you don't now need to work on a complete data. You can just work on a compressed format of the data. Now, there are various different benefits of it. One obvious one is that you get to implement algorithms faster, and you might end up having an algorithm which is much more accurate because you're reducing the noise and you're reducing the computation which is involved in it, right? So these are certain examples that we are seeing from a data pre-processing. There are many other methods, many other ways, but the goal of this notebook was to show you that how easy it is to do, what is the Google Colab format, and how does Google Colab helps us do data science / AI in this whole field. Machine learning models are essentially statistical and mathematical algorithms used by computers to trace patterns in available data. Many of these algorithms were available to mankind for a long time, but were barely put to use due to insufficient processing capabilities and shortage of available data. With today's advanced hardware capacity and increased efficiency of data storage facilities, ML algorithms are being used optimally. Today, the most commonly used ML algorithms fall under two major categories: supervised learning and unsupervised learning. The problem under supervised learning have labeled dataset, and algorithms built for regression and classifications are apt for handling them. Unsupervised learning problems work with unlabeled data and are often handled using clustering and association algorithms. Let's see some popular algorithms. Regression is the method of mapping independent variables to continuous dependent variable. The most common regression model is the linear regression model. The entire concept of this model is to fit the linear equation y equals to mx plus c to the data available. It is as simple as that. Simple problem statements which are known to have linearly dependent variables can be solved with linear regression model. The main difference in regression and classification is the nature of target variable, that is the variable which you are predicting. Under classification, logistic regression and random forest classification models are popular. Logistic regression, contrary to its name, is a classification algorithm. It follows the approach of linear regression. However, the values of the models obtained are processed by a function called a sigmoid function, which simply predicts the value based on probability. Random forest also supports regression and is often the go-to algorithm for several problems. However, it is important to note that the random forest regression model is bound to perform very poorly with the linear data due to its tree-based if-else approach. On the other hand, it works very well with the nonlinear data, where segregation with the if-else statements on different feature makes more sense. Random forest classifier, or RFC, uses several tree-like structures or set of if and else statement to form buckets or leaf nodes for the different classes present in the target variables. Same as for regression. RFC is best suited for nonlinear data. KNN, or k-nearest neighbor, is one of the most simplest and widely used algorithms. It can do both regression and classification. It's simply based on nearest points in data to figure out the predictions out of it. Support vector machines are also popular, but in recent years have gone down in demand due to its high computational resource requirements. Support vector machines like random forest can also be used for both classification and regression problems. Even though it is mostly preferred for classification tasks, support vector machines are good in handling high-dimensional data and are mostly used in images, text, and nonlinear problems. The model that we saw in the previous slides are extensively used on real-world problems and have had a good reputation in providing consistent performance over the years. The most common use case for regression models are house price and loan fraud prediction. These problems usually share a linear relationship with the independent variable. Random forest can be applied on classification problems like fake news prediction or mail spam detection. These use cases have categorical or discrete targets. KNN can be used to detect similarity in images by grouping similar image features together into clusters with maximum homogeneity. SVMs can be applied for anomaly detection problems which mostly have unbalanced datasets. They can also be used to predict sentiments of tweets. Deep learning is a subset of vast field of machine learning and is used to extract several layers of potentially useful features from raw data inputs. Unlike in machine learning, where useful features need to be prepared and fed to the models, deep learning models are self-sufficient and try multiple combinations of the raw columns in the data to formulate advanced features. Deep learning models are extremely efficient and give great results. They're also optimum for heavy dataset with a lot of features which might not be manually observable. The main advantage of deep learning over ML is its feature generation capability through its hierarchical methods of breaking down raw input into more abstract machine-relevant features. For instance, a picture of a dog can be broken down into 100 odd features, none of which might make any sense to the human eye, but be of extreme relevance to computer and machines. Here are a few deep learning models which are popularly used. Recurrent neural networks modify the simple neural network into one which can process inputs without any known limits. The most relevant features of the RNN is that it remembers the past and thus the term recurrent is used in its name. Therefore, RNNs not only learn from the current inputs but also remembers the past input. The long short-term memory or LSTM model is a unique in the sense that it remembers the other dependencies of the inputs provided. This becomes especially useful in the natural language problem since language has very structured format. LSTM can be of different types such as bidirectional or sequence to sequence. Convolution neural networks are primarily used in computer vision problems. They have the capacity of processing image data very fluently and carrying out a number of manipulative functions over the image features in order to bend them just right until converging patterns are observed. Among the most commonly used DL models, artificial neural networks are the simplest. They are a very raw reflection of the biological neural network. They have a set of nodes on each layer which are responsible for vector transformation, and each layer passes this transformed information to the next layer. This process continues until the output layer is reached. While going through deep learning, ANNs are one of the most important and basic algorithms that might encounter, and they also facilitate understanding of the concepts. Deep learning has vast set of applications, especially when the data load keeps increasing every day. The need for DL model also keeps rising. There are a few popular use cases which gives a type of neural network is most suitable for. For instance, recurrent neural network are used in sentiment analysis problems where we expect to identify the sentiment associated with a certain review, feedback, or comment. Convolution neural network, as already mentioned, are ideal for image data. They help to process image features intensively through its multi-layered network. Long short-term memory can be used for order-dependent problems like learning grammar of a language or a stock price prediction. These are use cases mostly dependent on structures or patterns of the data, and LSTMs are ideal for such scenarios. Artificial neural networks can be used for achieving better performance in typical ML problems like bank fraud detection or spam detection problems, since it can come up with features which may or may not be comprehensible to human mind, but will undoubtedly be useful to get more accurate solutions. So in this video, what we're going to see is we are going to use a deep learning model to do a prediction of handwritten digits, for which we are going to use a data set which is kind of a hello world data set. So this is a data set which is called as MNIST handwritten digit data. You can see the values of these data. So we have images of somebody who has written the digits in English. The goal of this data is that given an image, if somebody writes something in the digits from the English, can a model do a prediction of those things? So the frameworks that we're going to use for this is TensorFlow version 2 and Keras. These are two libraries that we have also discussed during the course, that these are one of the most important libraries if you have to do anything in the deep learning world. Now, the flow that will happen from the MNIST data analysis point is that we will first import the basic libraries. We will be reading the data set, which is the image data set. And one of the good things about this reading of the data set is that we're going to directly read it from the internet. So you don't need an external file. And we then are going to use the models from TensorFlow and Keras to do the learning that we want the model to understand, which is to say that we want the model to understand all nuances of these images for a specific digit, such that it can remember those patterns and then can do the fitting accordingly. And then we'll also try to analyze the errors of the model. We will see the accuracy of the model, and we will see how the model has learned better and whether it is able to do that predictions or not. One of the things which is important for this particular demo is that you need to make sure that your runtime is changed to GPU. So you can see that I've changed the runtime to GPU. I just need to save it. And then you need to make sure that you're connected to the backend. Every time you do anything on Google Colab, make sure that you're connected. So I'm just going to import a bunch of different libraries. So you can see that I'm importing TensorFlow, Pandas, NumPy. Seaborn is specifically for visualization. Matplotlib is a basic library that is used inside Python to spearhead every visualization which has to be created. So we are sort of creating this, and we are also printing the version just so that you know that what is the version that we are working on. So we are working on TensorFlow 2.2 and we are working on Keras 2.3. And this is where we are sort of downloading the data directly from the Kaggle. So you just have to run this particular line. One of the beauty of Google Colab and Jupyter Notebook in general is that you can actually run bash command. So you see wget is a Linux/bash command, and you have just to do a exclamation and then do the bash command. It will actually run it for you. Since you know that it is connected to a cloud platform, you can see that it gives you amazing speeds in terms of download. So we don't have to worry about waiting for it to be downloaded from that. Even though the data is not very big, but still, you will get good accuracies. So like I said, the first thing is that we're going to do a very basic pre-processing of the data. So you can see that the distribution of the data looks like this, that we have good amount of images for each of the values of digits 0 to 9. They are almost equal. Some of them are slightly larger or lesser, but on an average, they are almost equal. The first thing that we do is very common, that before we go ahead and do the modeling, we do the pre-processing just like we saw in the previous videos. Now in this data, what we're going to see is that we are making sure that the data that we have is properly normalized because the data that we are getting from the images is pixel level details, and they are essentially from 0 to 255. Now, when you have a data which is between 0 to 255, what you essentially want is to bring them into value range which is between 0 and 1. And that's very important because again, like I said, the algorithms are good when they have a single range to work on. So that's the kind of thing that we are doing, and each of these images have a pixel value, like I said, between 0 and 255. 0 represents black, complete black. 255 represents complete white. Everything in between is essentially something which is the shades of gray. Now obviously the colors that you see here is because we are using a different color grade for you to represent that, but essentially the images that you see at the very top of it are all in the black and white shade. That is why you have values between 0 to 255. Now that's what we are doing here. We are normalizing it. Once we do the normalizing, we are then going to label encode them. Label encode essentially means that we are creating vectors for each of the classes. So if you see here, what we are essentially doing is that, let's say if it is class 7. So rather than saying it as 7, we're going to say we're going to do a binary mapping. So we're going to have 10 different values, and whenever the value is present for that particular index, we're going to say 1 there, and then rest all of them are 0. So this is basically a vector for 7. Now this is where we are creating a vector representation of the classes, and it's a very important step. You would always have to do it because again, computers or models don't understand 1, 2, 3, 4, 5, 6. They understand 0 and 1 much better. So you would have to do that kind of label encoding before that. The next thing is we're going to divide the whole data into train and validation. This is a very common practice in deep learning and machine learning, that you have to first divide the complete set into train and validation. Train part of the data, so it's like, you're creating two different sets of data. The train part goes in the training of the model, and you don't send the validation to the model, because once the training is done of the model, then you try to do the testing on the validation set. So this is what we are doing here. Then we are doing a model building using a very basic CNN, which is a convolution neural network. Convolution neural networks are essentially built to do predictions out of images. So you can see that this is what the general architecture of CNN is, and how easy it is to sort of do that kind of a modeling from Keras' point of view, where you just have to mention all the different layers that are going to be part of your model. The next thing that we need to do after the model building, which is to say that we are first define the model layers. So one thing to note here is that model is still not running. It is just a defining phase. So we are just defining the layers of the model. Or the next two steps are something where you have an optimizer which has to make the learning possible. In this case, we are using a RMS prop. There are many other kinds of optimizers. You have gradient descent, you have Adam. There are many different kinds of available in this case. Once you have these optimizers, then the next step that you need to do is you need to compile. Once the compiling happens, this is where you will be able to sort of define that this is my optimizer, this is my loss that I need to minimize. Loss is essentially that how do you want the network to understand whether it is learning good or bad. So that's what we are defining here. And then right after defining that, we are also defining something which is learning rate reduction. Learning rates are essentially a way for you to control the learning of the model. So rather than you defining the value, we're using a function which is automatically doing it for us. So this is kind of a hyperparameter tuning, which is what we are dependent on a library to do it for us, and we are not essentially doing it manually. We're also defining the epochs and the batch size. Epochs and batch size are essentially how many times you would like the model to go through the data again and again, which is that it is going to go through our data 30 times again and again so that it can sort of do the learning that we want it to learn. Because if it does only one time of a pass on the data, it might not learn very well. The next step that we are doing is we are creating some more data points out of the data that we have. So this is what, you can sort of think of it like a generator of your data, wherein it produces various different kind of variations of your data. Now this is again important because we want the model to understand all different kinds of variations which are available. So you can see that I'm essentially writing certain rotation variations. I'm also writing zoom variations. So essentially what will happen is your images will be zoomed out, zoomed in. You will have a rotation in the images. This is again to address various different kinds of new images or the new data that is going to come, so that you're preparing your model to understand all variations. The last step is where we do the model fitting, which is what we are using as model.fit generator. This is where the model starts training itself. So you can see that it goes on for a longer time. It'll take some time when you'll actually do it. So these are all the different steps it will automatically do. And this is why GPU is important, because GPU will be able to learn all these things in a much more detail. Now, if you see the learning curves of your model, which is to say that this is where your model is essentially showing you that how good it has learned. So the loss and the accuracy will always be flipped. So loss has to go down because we want the loss to be 0. The accuracy has to be 1. So always remember, this is why the curves that are showing is that we are reaching a very good accuracy on the validation data. So we have trained everything on training data, and now we are testing it on the validation. And on the validation, it is sort of telling us that, hey, we have come to the loss which is almost at 0 and the validation which is almost at high. Now, similarly, what we do as a next step is we also draw the confusion matrix just to look into individual predictions and see that what are the different kinds of errors that we have, which is what I'm plotting in the next case. So now you can see that these are the errors which has been done by my model. And these are some of these errors are very important because any model would have been confused by that. So for example, if you see this was 6 and it was predicted as 8. Similarly, this was 5 where it was predicted as 6. So they have some confusion which is there. So this is where you will actually go back and try to do a different model. So that's what you saw in this video, wherein you were able to see that how easy it is to sort of go through a complete cycle of modeling from a deep learning perspective and do a prediction which can do a handwritten digit prediction from an image point of view. So in this video, we're going to see another example of machine learning prediction. Now, for this machine learning prediction, we are going to use a house price data, which essentially has prices of all the houses in New York. And this data essentially is given in order for us to understand the property patterns of a New York City. And then based on those patterns, can you actually make a prediction of a price of a house? That in the future sense, when you get a new property, will you be able to predict the price based on different values that we have in the data? So in this video, what we're going to see is we're going to see how to load this data. We'll do some basic pre-processing, some basic analysis on the data, and then we'll directly see how to build a model out of it. So when we'll start, you can see that we are importing bunch of different libraries here. So most of the essential ones are still used. So you have sklearn, you have pandas, you have numpy. Again, sklearn is scikit-learn, which is the machine learning libraries where you have all required functions and algorithms for you to do anything in machine learning. The next thing that we are doing in this is we are downloading the data directly from Kaggle. This will be again something which you can just run. You don't have to log in anywhere. You don't have to put anything. You just have to run this, and you can again see an example of doing a bash command. Once we download the data, you would have to unzip, which again you can just directly do by this command. Once we are done with this, we can essentially have a look into the data. So you can now see the data. It has a bunch of different properties of a particular residential / commercial property. So you have area of lot, area of frontage, what is the utilities that are provided, what are different conditions that are there of a given property, what is the overall condition, which year what was it built, when was it remoded, and there are many different. So you can see that there are close to 81 columns. So it's a very big data in a sense that you have almost 81 different columns. But the data set that we are taking has a very small amount of rows because we are taking a very small subset of the data, which is only 1460 records. Essentially what we have towards the end of it, if you notice, is a sales price. So these are the sales prices in dollars. So for each row, you can see that we know the property prices as well. So now the goal, like I said, is to take all the columns that we have, understand the patterns, and make the model understand how to predict the price. Now this is a regression problem. Regression problems are problems where you do a prediction of a continuous value. So once we do the loading of the data, the next thing that we do is we try to understand some distribution of our target variable, which is sales price. So if you do the plotting of it, you can see very well that this particular data is slightly normal, but you do have certain outliers in the data, which you see after $400,000 record, you have actually some properties which are beyond that. Now this brings to us a question that whether for this analysis you would like to take this into consideration, because this might be a very posh property and you don't want to add this bias into the analysis. So you might go ahead and say that, hey, maybe for this analysis I don't want to do that. And that's what one of the aspects of this data point is. So that's a decision that you can make, and you can do a pre-processing by clipping those details, just like we saw in the older videos, that you have a way of clipping certain outliers in your data. The next thing that we try to do in this data is we try to see that do we have any missing value or the NA values, and we have a lot of in this data, which is what we are writing a function to get a detail of. We are using a similar function which we have seen in the previous demos, which gives us the ratio or the number of how many missing values do we have. So now if you see the tally of this output, you can see that lot frontage has 16% missing values, which is a very huge number. So what we do in this case is we are essentially dividing the whole data into two formats. One, we are saying there are numerical values, which are continuous numerical values, and then there are values which are purely category, and we are trying to impute both of them. We are trying to fill both of these missing values. So on the category side, we are filling it up with none. So we are creating a new category which is none rather than using a NaN. And on the numerical side, we are filling it up with a zero value. So which is to say that any numerical value, we are just going to impute it with the zero value. So that's what we are doing in terms of pre-processing, and that's what one of the things that we are doing. Now, another way to do a categorical imputation is to replace it with the mode, which is what I'm doing here. So I'm basically taking the mode of the column, which is the high frequent value, and I'm replacing it with that. So again, these are different ways you can sort of do this in Python, and you'll be able to sort of play with this from this point. The next thing that we are essentially trying to do is we are also trying to understand the data correlation. Data correlation is essentially that maybe if there are some columns which are highly correlated to each other, we can drop one of them, because we don't need to take both of them, because both of them are going to give us the same level of predictions from that point. So that's what we have here. So you can actually see that we have a very beautiful heat map which is sort of showing us. We also have a legend of the value. So anything which is towards the blackish side, we have a negative value of correlation, like highly negative. Typically, the range of correlation that we always look for in terms of threshold is anything which is beyond 0.8 from a positive and 0.8 from the negative. So if you have anything beyond that, we try to get rid of those columns in terms of pre-processing. So that's what we have here. Once we are done with this, then the next thing that we're going to do is we're going to do a categorical and label encoding. Now, like I said, computers don't understand categories, so you have to do a conversion of them to a label encoder. Label encoder essentially means that you're giving a numerical representation to the category, because again, any categories which is written in an English format is not understood by computers and models. So we need to create a mapping of 0, 1, 2, 3 or something which is numerical, so that the model understands that these are different kinds of category. So that's what we are doing here. We're also trying to do a dummy conversion, which is what one of the encoding we have. Dummy essentially means that you're doing a binary encoding in this. Now, once all these pre-processing is sort of created, the next quick thing that we do is we run a model for the model to understand the patterns that we have in our data, for which we are using a very basic regression model. This regression model essentially takes the data that we have given to it, and it'll try to learn the mapping between 80 columns that we have and the remaining target column, and it'll try to figure out how to predict that. And that's what is happening. And what we are using in this as a measure of calculation in terms of accuracy is the mean squared error, which is to say it is just simply whatever you predict minus the actual, and then you do the square of it. And this is what we mean by mean squared error. Then we do the average. So which is to say that what is the average deviation we are expecting out of the model that we have learned. So once we do the model, you can see that we have the mean squared error, which is 36,637. Which is to say that on an average, when you are doing a prediction using this model, you will see a deviation of $36,000. So whatever value you predict, it might be plus of 36,000 or it might be less of 36,000. So that's the first very basic modeling that we have done. This is what you go in detail, and then you keep on doing these changes in the model. You keep on iterating from this point, and then you get to a point where you have a model which gives you less and less of deviation. The goal is always to have a least amount of deviation so that your accuracy of the model is good. Now, once we do this model, it's very easy to do the prediction of the new values. You directly have a function of .predict, which is where you'll be able to do a prediction of the new data points. So in this video, we're going to see a problem statement, which is pilot distraction prediction. What we have in this data is very simple, that we have a EEG recording of a pilot while taking a flight, and our goal is to see whether he is distracted while doing the whole flight process. Now in this case, let me show you data. So data can be easily downloaded through Kaggle. We have given you a way of doing that. Once you have the data, let me sort of show you a data what it contains. So it has multiple different EEG values. So you can see that you have FP1, FP7. So these are different EEG recorded for a pilot for the whole time when he was in the flight. We are also given a time frame. This is all the time frame which is encoded in the second. So you don't know the actual time of it. So this value is animized for all the others to sort of make sense. And the last column that is of importance is the event. Now event is what the aviation industry defines it into different kinds of cognitive states. So there are four essentially. One is the baseline, which is represented as A. The B is SS. SS is something which is induced by having the subject watching a movie clip or with, jumping out of scare because of watching it. Then you have C, which is CA, which is state of being focused on one task to the exclusion of all the others, which is the good state to be in for a pilot. Then we have DA, which is the diverted attention, which is sort of understanding that he's not essentially focusing on a single task. He's being diverted by actions, which is sort of not good for a pilot, because which is to show that he's not really focused on flight and he's sort of being distracted by something. Now the goal of this data is very simple, that given these different EEG recordings, can we make a prediction that when a driver is having a diverted attention, or when the driver has a baseline which is normal, there's no channelized, there's no diverted, he's just normally operating it. Now in this data, if you see the distribution of all the recordings of the EEG with different times, you can see that the baseline, which is the normal distribution, is slightly higher compared to the C, D and B being the most least amount, which is what the diverted attention is. And B is the concern that we have, that whenever we get either the B or the D part was something which is the DA and the C part was the CA. Now all these B, C and D are something which is of an importance, but more importantly, the goal of this problem is to focus only on the B and the D part, which is why you see that the B and the D part is very small, because this is where a pilot is distracted and he's not doing what he's supposed to do. So we do a very simple analysis on this data. We sort of try to see what different experiments are being done, how it is relating with CA and DA, what are different kinds of states that we have, which seats are they on, whether they are on the left seat or the right seat while being at A, C and D and B. So there's not much of information here. We also see that with respect to time, how these things are being differed at. So given a particular event, what is the timeline that they are expanded into? So when they're doing B and D, how much are they doing it as compared to the A and C kind of a thing? So we also sort of try to see from this point. Now we also are seeing different EED recording with respect to the A, C, D and B. So all different EEG recordings, you're basically able to see that how they are differing with respect to all the other specific analysis of those things. Now this gives us a good understanding, and you can also see the power of Python visualization, that it's so easy to sort of create visualizations by writing just a very small part of the code, and you're able to see individual EEG distributions and their value distributions using box plot from those points, which sort of gives you an understanding that for a specific B and D which is of your concern, how are they different from the A and C, which is the normal. So again, just to do a quick recap, the A and C is normal and the D and B is what we are having a concern on, which is what we want the model to understand. We're also making sure that the trained data, the validation/trained data, has a very similar representation of the EEG compared to the test data. So both train and test are something on sync. Once that is there, we are trying to make sure that we have both of them similar. So if you see one of the examples of this, so this is electrocardiogram signal distribution. So you can see that how there are some peaks sometimes, which sort of gives us an understanding that there is some definite issues in those peaks and we need the model to understand that. We also have respiration signal distribution. So these are all part of the EEG, and we are sort of trying to understand that do we have any specific patterns in it, and which is what we would want the model to understand. The third type of EEG that we have is galvanic skin response. That also is something where you see certain peak, and we would like the model to understand those patterns. And again, we are trying to see this data because we are also trying to understand whether we have a good representation of these things or not. Now what we're doing in this case is we're using a very basic machine learning model, which is called as gradient boosting, or GBMs, or another variations of this is called as XGBoost. Now this is a very powerful model which sort of helps us understand very different and complex kinds of data sets, and this is what we are sort of trying to do here. So we are utilizing gradient boosting, and you can see that we are running the model here, and we are able to run the whole model. Once the model runs, it sort of also helps us understand the feature importance, which is to say that which of the features, which of the columns that we have provided to this particular model seems to be more important from this point of view. So you can see that it has given us some basic definition saying that these are the EEG recording and GSR recordings which are important. Similarly, if you see the confusion matrix of it, you can actually see by the end of the whole thing. And like I said, our focus is on the B and D. So you can see that the accuracy, the individual accuracy of both B and D is standing at 97 and 94% respectively. Which is to say that we still have some issues of doing a prediction. Not all of them are predicted properly. So we will again go back to the model. We will try to analyze what went wrong, what kind of hyperparameter tuning can we do on this. On that note, we will try to understand what is the hyperparameter tuning we need to do on these models, and we will make the model go in a direction where we'll at least get 100% accuracies on B and T. Because again, it's very crucial to have 0% error on these things, because any percent error that you have, even if it is 0.1, might lead to a fatal accident, and this is what we don't want it to happen. So in this notebook, we're going to see State Farm driver distraction problem, which is to say that we have a bunch of different images, and on those images, we have to make the model learn that when the driver is distracted, so that if you deploy this on a dash cam can then notify the driver or the authority that the driver is being distracted and he's not properly driving the vehicle. Now this data is available on Kaggle, but you can actually download this data through the link that we have given in the notebook. So we'll do the proper steps. So we'll just import all the libraries. So you can see that in this we are using a lot of keras and a lot of different layers of keras that are available to us, which will help us build the AI model. So we are downloading the data from the Kaggle directly, and then we are unzipping it. One thing to note is that this notebook also will require a GPU backend. And you won't be able to run this on a CPU. So we know how to do that. You can just go to a runtime and make sure to select a GPU backend from here, and then just connect to that backend. Another important point to remember in this is that this is going to be a very huge data. So I would request you to do this notebook only on Colab. And it'll take sort of 51 seconds to download directly there. So this 4 GB of data is quite huge. The reason it is huge is because we are using clips which are videos and not just the images. Now we have just downloaded this, and then now we are doing the unzipping. So you can see that all these images which we have are being unzipped, and they are unzipped in a specific image, which then combines together to form a video that we have to do. In this notebook also, we have written a lot of functions. These functions are going to act as a placeholders for us to call them again and again, rather than writing individual functions out of it. So the first function is to create the batches out of our data. So rather than sending complete data to the model, we are going to create different batches. We also have a function that can do the plotting quickly, so that we don't have to write the individual plots. We have a function that can do a get classes, which will help us understand what are different classes that we have. So when the driver is distracted, there are overall 10 different distractions that we have in the data set, and we have written a function which can get those classes. We also have a get data function which will automatically get the data from the data that we have just downloaded. Then we have some basic functions which will save the array whenever there is a manipulation of the array which is needed. Similarly, load array will also help us with that manipulation. Then we have two basic plot history and plot accuracy, which will help us do the plotting of either the accuracy or the history of the model that we are doing. So once that is done, let's see what are those 10 different distraction behaviors that we are trying to get in the whole data. So you can see that we have from C0 to C9. So the first one is safe driving, which is the default state which we want every driver to adhere to. And that's why we are also telling the model that these are the safe and these are the not safe. Then C1 is texting right, whether he's using his right hand or the left hand, talking on the phone right, texting left, talking on the phone left, operating the radio, drinking, reaching behind, hair and makeup, talking to a passenger. So you can see that there are so many different distraction qualities that we have in the video, and we want the model to understand. Now, one of the things that we are doing in this is we are restricting the overall model to only 5 categories. We are not taking all the ones because, like I said, this is a very huge data set and it'll take huge time for you to run this. So we are restricting that just to sort of make sure that we are able to train a model in that category or not. So the categories that we are taking is, you can see it here. So we are taking from 0 to 4, which is to say the first 5 that we are discussing here. So essentially all the texting versus the safe driving. So the model will be going to be a model that can understand safe driving, texting and talking. So these are the 3 basic classes which are divided into 5 is the main point of our whole analysis. So what we are doing is we are essentially defining those classes, then we are essentially creating the float and the class labels out of it. Once those things are done, we are just plotting them just to see it. So this is where you'll be able to see that how we are using the functions that we have written in the previous. So you can see that we have picked out those images and we are able to see what each image represent, whether somebody is texting, they're talking to the customer, or they are just dialing something, or they are just looking at the phones and things like that. Now, once we are done looking into the data, we'll start with the first linear model. Now, linear models are basic models. They are not very comprehensive AI models, but they are just for us to understand that how basic models has an effect on overall accuracies of the model. Now, the first thing, like I said, is the sequential model, which is basically just a simple layer and doing a linear predictions out of it. And we are essentially doing a fitting using that linear model. Now you can see that once we do run that, the validation accuracy that comes out is 92%, which is very less because we are essentially saying that out of all records that we are sending in the validation, only 92% of them are being predicted correctly. So we still have 8%, which is not good in terms of the accuracy. So what we do next is we go ahead and build a convolution neural network. So you can now see that we have a comprehensive model that we are building from the basic that we have started. Once we have a CNN model, you can see that we are creating a very comprehensive CNN model here. And then once this is there, now you can see that the accuracy has increased and it has crossed automatically to 99.6%. Now this is a huge jump that has happened from 92% to 99%. And that's a good thing. However, in terms of AI and machine learning, we typically call such things as overfitting because 99 is not a good indication. It might be the case that your model is trying to overlearn everything, which is to say that in such cases, you might go back and maybe try to include more classes. Maybe you want to create different kinds of validation, and there are a lot of things that you would want to do. But the goal of the whole notebook was to show you that how easy it is to take a video / image kind of a data and do something which is so common, which has a huge potential in terms of use cases, and see how easy it is to just do a simple validation process, simple modeling process, and you will be able to do a predictions out of it. At the end of the course, let's quickly summarize what we have learned in this. In this course, firstly, we learned about different ways of programming in Python in Jupyter Notebook and Google Colab, a brief intro of features of both Jupyter Notebook and Google Colab. Next, we went through a step-by-step process of setting up a basic Python environment by installing Anaconda. Also, we learned about different benefits of Anaconda environment in AI. We also covered the comparison between Datmo and Anaconda. Then we learned about the basics of ML model, which are commonly used in the industry and its application. We also saw different demos for implementing different machine learning examples in Python, like handwritten digit detection. Lastly, we learned about the basics of a DL model, which are commonly used in the industry and its application. We also saw different demos for implementing different deep learning examples in Python like house price prediction, distracted driver detection, etc. Coming up next is the Computer Vision for AI course. In this, we will see how computer vision is currently used across various industries, and we will see some of the specific examples along with the comprehensive and interesting demos.